Hello everyone, let me introduce myself. I am Facundo Carballo, and today we will see how to create a decentralized application oriented to NFT from scratch. So we have to think about the design of the web application, we have to create the web application, and also the smart contract and the interaction between the smart contract and this web application. For this case, I decided to deploy this smart contract on Rinkeby and also on the Binance Smart Chain Testnet. So this Dapp will support two blockchains, the Rinkeby and also the Binance Smart Chain Testnet. Depends on the user. If the user is connected to, for example, Rinkeby, the Dapp will connect with the smart contract on Rinkeby, and if the user is connected to Binance Smart Chain Testnet, the Dapp will connect with the contract of the Binance Smart Chain Testnet. To interact with this Dapp, you will need some fake ETH or some fake BNB. So to get that crypto, you can visit the faucet of Rinkeby ETH or the faucet of BNB fake. And you have to paste your address account and you will receive some crypto on your wallet. I will let you on the description of the video the links to these faucets so you can get some fake crypto to interact with the Dapp and so on.
The main idea of this project is that anyone can create his own NFT using a Dapp as an intermediate. In this Dapp, you can see all the NFTs created by all the users, and also you can search for a specific NFT. Each NFT will have his own section where it will show his photo, his name, and his description of the NFT. Also, each user can offer for any NFT with crypto and wait for the owner of the NFT to accept or not his offer. If the owner accepts the offers, the NFT will transfer automatically to the wallet that made the offer. The owners of the NFT will see the page of his NFT differently from the rest of the people, because they will see in each offer a button to accept the offer. On the other hand, the users will have the possibility to cancel all the offers that they made and recover all the funds spent. All of this you can do from your smartphone too. To do that, you just have to go to your preferred wallet, in my case MetaMask, and then we have to go into the browser that this wallet provides and insert the URL of the project. You will have the link to the project in the description of the video.
Well, before I let you with the creation process of this project, I like to say that the main important thing when you are creating some project or whatever is the organization that you have to get this project done. Because if you are organized and you know what you want, the development process, it will be more easier and agile and safe also. Because when you know what things you have to do, you will be more focused on those things that you have to do, and at the end of the day the result will be better. So before you start coding anything, it's really recommend that first you know what things you have to do, and once you know what things you have to do, then start to coding.
When I had the idea to make this video was that you can see the process that I follow to get the project done. So first of all, before I start coding anything, I like to design the user interface to be able to see what functions I will need. Making the design before start to coding will save a lot of time and will make your project more pretty. Because when you use tools like Figma to design, you can use the mouse on just drag and drop figures, image, and so on. It's very easy to design with these tools, so you will always get a beautiful user experience if you design your project first on Figma or any design tool, and then you code the app following the design that you made. One more important thing to consider is that you have to be sure that all of your design you have to be able to do with the code. So I recommend that you think that you will have to implement your design on code. In this case, for this project, I designed all the pages before I start coding, both for desktop and for mobile. Once we have the design of the Dapp done, we can start to develop the smart contract. The smart contract will be the heart of the project. In any blockchain project, everything that we want to happen inside of the Dapp, we have to define it on the smart contract. I like to say that you have to see the smart contracts like a database. From here, we will be able to read and write data using only the public functions that our smart contract has. Because of that, it's very important to define well which functions will need to read the data that our Dapp demands. And also know what function will be necessary to make the functionality of the project. We will need some public variables to store important data that we need to make decisions in the functions, as well to read that information from the Dapp. If you can see, in the code of the smart contract, I made some comments that indicate the finality and how to implement each variable. For example, you will see that at the beginning of the smart contract that I made the comment NFT. That means that the variables behind it will be related with the NFTs. The same for the offers, aux, and functions. Starting with the NFT variables, I will need 3 mapping functions that handle the name, photo URL, and description of each NFT. That is because I decided not to work with URIs and just work with the contract itself. After that, I will need another mapping function that returns all the NFTs that the user has. At the right of each variable, I made a comment explaining how to use the variable. After that, I will need another mapping function to tell me if the user is the owner or not of an NFT. Going to the field of the offers, I will need to identify each offer in each NFT. Also, I will need another mapping function that returns the last offer accepted from each NFT. That is because knowing this, I can show on the Dapp the offers for an NFT since the NFT changed the owner. Like the offers will have an amount, an owner, and a volume mark which indicates if these offers are still available or not. And for that exist these 3 mapping functions. Also, I will need another mapping function to know how much this wallet offers in total. I decided to call this variable offer balance. So if one person offers 10 ETH to an NFT and then offers 15 ETH to another NFT, this person will have in his offer balance 25 ETH. This data is useful to control how much the contract has to recover to the user if the user wants to delete his offer. This is only for if the user wants to delete all of these offers at once. But if the user decides to delete his offers one by one, I don't need to use this variable. Lastly, I will need these mapping functions that returns me an array of all the offers ID that the user has, and another mapping function that returns the NFTs IDs from each offer. These two arrays have to have the same length because every time that the user makes an offer, the offer ID is stored on the getOfferID mapping, and the token ID is stored on the getTokenID offerID mapping. And well, at the end, you can see that I create an empty array. These arrays will help me as an aux in some situations inside of the functions. Now, we will start to see all the function of the smart contract in Dapp, and we'll understand the why of each variable and mapping function. To satisfy the needs of the project, we will need to implement these functions. Create NFT function. This will be called every time that some person wants to create his NFT. This function will receive three parameters of type string, which will represent the name, the description, and the image of the NFT. Inside of the function, we get the actual token ID, and then I have to increment the token ID. After that, we have to mint the NFT, and also we have to store all the data that we receive from the parameters. So we store the name, description, and image NFT using the mapping functions that we reserve for that. Finally, create an empty array of ints, and we have to aggregate the keyword storage to store this array permanently on the blockchain and not just for the lifetime of the function. To this array, we assign all the NFTs of the user using the mapping function that handles that. Remember, if the mapping function doesn't contain anything, it will return an empty array of integers. After that, I will just add the new NFT to this array, and then I will set the mapping function with the new array of NFTs. Make offer. This function will work to make offers to NFTs that we want to be the owners. The function will receive as a parameter an integer that will represent the token ID of the NFT that we are offering. This is a payable function, so it will be watching how much crypto the user sends when the function is called. The first thing that we see on this function is a require, requiring that the token ID that the user passes as a parameter will be less than the number that the token ID variable has, because the number of the token ID variable will be the token ID of the next NFT that will be minted. So actually, the NFT with the token ID variable doesn't exist yet. After that, we set the values of the offer using the mapping functions that we reserve to that. If you can see, I am using another mapping function inside of this, because with getOfferID, I'm getting the offer ID for this specific NFT. This ID works identically like the token ID. This ID will be incremented by 1 every time that this NFT receives an offer. Each NFT has his own offer ID independently of the others. After that, we increment the offer balance of the user that made the offer, adding to this actual balance the amount of crypto that the user sends to the function. Now, we can call a function called addOfferToTracker, who receives 3 parameters: the wallet of the address that made the offer, the token ID, and the offer ID. This function will get the offers that this user made on all the token ID of these offers. Once we get that, we push to each array the corresponding offer ID and the corresponding token ID. And finally, we set the values of these mappings with these arrays updated. Returning to the offer function, we just have to increment the offer ID for this token, and we finish the function. Delete offer. This function will receive 2 parameters, both integers. The first one will represent the token ID, and the last one will represent the offer ID. This function will be executed only for the owner of the offer. Because of that, it's that we have to aggregate this first require. At the same time, we have to make sure that this offer is currently open. So we will have to add another require who watch the status of the offer. After that, we refund the user with the value of the offer. We have to inform to the blockchain that this offer is now deprecated. We reduce the offer balance of the user and we update the arrays that store the token ID of the user are offered to. And obviously, the array that store the offer ID of this token ID. Delete all offers. This function doesn't receive parameters, but to be called, we have to have some requirements. First, your balance donation have to be greater than 0, and also your array of tokens offered have to contain at least one token offered. After that, we refund the user with the value that marks the offer balance. After that, we set all the offers of the user like deprecated. We update the array that contains all the token ID of the NFT that this user has offered, and the same with the array that contains all the offer ID. Finally, we have to update the offers balance. In this case, we just have to set it to 0. Accept offer. This function, like the delete offer function, will receive two parameters as integers. The first one will represent the token ID, and the last one will represent the offer ID. Inside of the function, we have to guarantee that the wallet that calls this function is the owner of the NFT, and that this offer is still active. We verify this using the require function, and then we send the NFT to this new owner, and after that we send the amount offered to the wallet that calls this function. Lastly, we have to set this as the last offer accepted and turn off the offer. After that, we compile the contract and then we deploy the contract on Rinkeby and on Binance Smart Chain Testnet. All of this using Remix. This is so much easier than deploying with Raffle. I know that Raffle may make some troubles to you, especially for those that are using Windows, which are the majority. Lately, I'm working with Remix only to create my contracts, to test it, and to deploy it. After that, I just have to connect my Dapp with this contract using Web3. Once we have our smart contract created, now we start to develop the Dapp. I like to work the front end of any web application with React, Next.js, and a component library called Chakra UI. If you don't know about Chakra UI, I really recommend you. Makes much more easier the process of develop a web application. On my channel, I have a video where I explain Chakra UI in detail. So back to the Dapp. We already have a design on the Figma of our Dapp. So we already know what we want to do. So now we just have to try to copy the design on Figma in our React Dapp. Remember that you will have all the code of this project on my GitHub repo. I will not explain every detail of how I create the design of Dapp because I will be a few hours explaining that. So if you want to see how I create the entire design of the Dapp, you can check it out on my GitHub repo. Once we have the design of the Dapp done, we have to create a connection between our Dapp and our smart contract. To do that, I like to have all organized inside of the folder source functions. I create a JavaScript file called web3.js. Now we have to go to Remix again because we have to copy the API of the contract. We need this API to interact with our smart contract. So we have to compile our smart contract, and then we will see a lot of new files inside of the folder artifacts of our smart contract. We search for the file called name of the contract underscore metadata.json. We have to copy the entire file. To paste this JSON file, I create a new folder inside of the folder contracts called ABI. Here I create a new JSON file, and then I paste here the metadata that we copy on Remix. Now, inside of the Web3.js file, we can start the connection with the smart contract. To do that, we have to import Web3 and the JSON files that we get from Remix. It's important that before you import Web3, you have to make sure that you install the npm package of Web3 using this command. Once you have Web3 installed, you will be able to import Web3 correctly. Like I have my smart contract in Rinkeby and in the Binance Smart Chain Testnet, I will implement a function that handles this management of multiple blockchains. I create the function in another file of web3.js. This function will receive a number as a parameter. This number will represent the ID of the blockchain that the user is connected to. After that, I create an array of blockchains with just 2 blockchains. When the function finds the correct blockchains that it receives as a parameter, returns the correct blockchain from the array. If the function doesn't find the blockchain, it will return null. I invite you to use this code. You can find it on my GitHub repo, and you can also add more blockchains to this array. So together we can create a more complex function that handles the majority of the blockchains. Add a blockchain to this array, it's simple. You just have to create a variable inside of the file with a name that represents the blockchain to add. And you have to indicate to this variable that it's the type iNetwork. That is because we are working with TypeScript in this case. After that, you have to pass it the name, the RPC, the ID, the symbol, and the URL of the scan of this blockchain. Once you have your variable done, inside of the variable networks, you just have to add your network to the array. Doing that, the blockchain is already in the function, so if the user is connected with this new blockchain, your Dapp will know about that. Back to the web3.js file, we continue creating the global variables like the contract, the address of the contracts, and then we can start with functions that get and set data to the smart contract. We create a function to handle the connection of the wallet of the user with our Dapp. To do that, I always use the same function that I call loadweb3. You can get this function on my GitHub repo and just copy and paste on your code. To get the data that I will use frequently in the Dapp, I will use a unique function that I call loadData. I will call this function when the dApps connect with the user wallet, and all the data that this function returns, I will store it in a context. That will allow me to have in all the Dapp this data, so I don't have to be calling this function every time. In this function, first we get the address of the user wallet, the amount of crypto that this user has, and the ID of the blockchain that the user is connected to. To do that, I use a function that I call loadAccountInfo. This function uses just Web3 to get all of this data. The blockchain ID will be an important data. This ID will indicate how we set our contract. Because if the user are on Rinkeby, we have to create a contract using the contract address of Rinkeby. And on the other hand, if the user is using Binance Smart Chain Testnet, we have to create the contract using the contract address of the Binance Smart Chain Testnet. After that, we call the function that returns the blockchain with this specific structure. and we pass the blockchain ID. If this function returns a value different from null, we set our provider with the RPC of the blockchain. If the function returns null, we just print this message on the console. In this case, like we don't set our provider with any RPC, our Dapp will fail. But I handled that on the frontend to show a message telling to the user that is connected to an unsupported blockchain. We continue creating our instance of the contract. To do that, we use the contract function that we got from the require, and we pass to this function two parameters. First, we pass the API of the contract, and as a second parameter, we pass the contract address. Once we have our instance created, we get the amount of NFTs that the user has. To do that, we use the instance of the contract that was created before, and we will use some method from this contract. In this case, I will use the method balance of. Like to call this function, we have to pass some address. We pass the address of the user. Lastly, like this is a view function, it doesn't consume gas. We just have to call it using the method .call. It will be different if we want to execute some function that modifies the state of the smart contracts, because that function will consume gas. But we will see that in a few minutes. Now, we know the amount of NFTs that this wallet has. But if we want the NFTs itself, how can we know that? To do that, I create a function that I call getMyNFTs. And to this function, I pass the contract address, the address of the user, and the amount of NFTs that this address has. Inside of this function, I create two empty arrays. One will store the ID of the NFTs, and the other will store the objects of the NFTs. So first, we get the IDs using this for loop, and then we get the object of the NFT using the function getNFT. This function just gets the data of a specific NFT and returns the object of the NFT. So back to the getMyNFTs function. This will return the array of NFTs objects that we get from the second for loop. And this data is what we get from the load data function. Lastly, I will show some functions that need to spend some gas, like create NFT or make offer. First, we will see the create NFT function and then the make offer function. We will know that the implementation of this function are very similar. To implement the create NFT function, we will need the instance of the contract to call the create NFT method. This method will receive three parameters: the name of the NFT, the description, and the photo URL. So like this function consumes gas, we inside of calling the call method, we have to encrypt this function using the encode API method. We store the encode API in a variable that I used to call it data. Now we have to get the nonce of the user. We can do that just using a Web3 function like you can see. Now with the encode API and the nonce, we can get an estimate gas for this function. This estimate gas represents how much gas this function has to use to update the smart contract. So to get this estimate gas, we have to call the method just like we did before to get the encode API, but in this case, you will end the line calling to the estimate gas method. You have to pass it an object that contains the nonce, the wallet address that are calling this function, and the contract address. So now we have to send this encode API to the user wallet to sign the transaction. To do that, we have to create an object that I call params. This object will contain the address of the user, the address of the contract, the estimate gas, the gas price that I normally set to 50 GWh, and lastly, the data that we get in the first place with the encode API. The gas price will determine how fast your function will approve for the blockchain. You can see the actual gas price going to this website, and you will see the price and how much time it will take the functions. With our params created, we just have to interact with the wallet of the user. So to do that, we have to use this Web3 function, and we pass here the params object, like an array. I add some additional functionalities when the function finishes, like show on the screen the transaction ID, and if the user clicks here, it will redirect to the scan of the blockchain. If you see the code of make offer function, we can see that it's very similar. First, we get the encode API. After that, we get the nonce. Then we get an estimate gas. With all of this data, we can create the params object, and finally, we send these params to the Web3 function as an array. So this is the basic implementation of a function that changed the state of the smart contract. So all the functions from this contract that change the state will be implemented in the same way.
So I hope that you enjoyed the video, and if you like this kind of videos, you can hit the like button, and of course you can subscribe to my channel too. And if you want to say me something, you can comment and I will read your comment. See you on the next video.